Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. When it comes to network troubleshooting, few things are more fundamental or more frequently overlooked than cable testing tools. Whether it's a user complaining of a dropped connection or a switch reporting repeated ZRC errors, the problem often comes down to the simplest layer: the cable. Miswiring, poor termination, and unseen physical faults can cause a cascade of seemingly complex network symptoms. Field technicians who are well-versed in cable tool usage not only resolve these issues faster, but also avoid unnecessary escalations and equipment replacements. For certification exam takers, this knowledge is equally important. Identifying which tool to use, when to use it, and what its output indicates is a critical skill, both in testing and in the field. In this episode, we'll walk through the key physical tools used to create, repair, and verify network cables. These include crimping tools, punchdown tools, continuity testers, certifiers, tone generators, and more. You'll learn how each tool functions, what it's designed to test, and how to recognize when it's needed. Understanding cable tools gives technicians power over the most foundational element of networking, Layer 1. And when the physical layer works, the rest of the network is that much easier to troubleshoot. Let's start with one of the most essential tools in any field technician's kit, the crimping tool. Crimpers are used to terminate cables with modular connectors such as RJ45 or RJ11. These connectors are attached to twisted pair copper cables, usually as part of creating a patch cord or repairing a damaged one. The crimper presses metal pins into the individual conductors, securing them and creating an electrical connection. Without proper crimping, the cable may physically appear complete, but will fail to pass data or may only work intermittently. Crimping tools are available in various designs, but all perform the same basic function: seating and securing the connector to the cable. Errors during crimping are common, especially for less experienced technicians or when rushing. Misaligned wires, pins that don't fully seat, or connectors that are crimped onto stripped insulation rather than bare conductor are frequent mistakes. These faults can cause complete link failure or inconsistent behavior depending on which pairs are affected. The result may be a link that lights up but doesn't pass traffic, or one that only negotiates at 100 Mbps instead of gigabit. After any crimping job, it's essential to test the cable using a continuity tester to ensure proper function. Best practices for crimping begin with using the correct wiring standard. In Ethernet networks, T568A and T568B are the two accepted pinout schemes. Both are valid, but both ends of the cable must match. Mixing them results in a crossover cable, which is only appropriate in specific use cases. Always use high-quality connectors and a reliable crimping tool. Cheap tools often fail to apply even pressure or wear out quickly. When terminating, ensure the cable jacket is properly secured within the connector to reduce strain on the conductors. And once the cable is completed, test it before deploying it into a live environment. The punchdown tool is another critical item in cable installations and repairs. Unlike crimpers, which work with modular plugs, punchdown tools are used to seat wires into fixed termination points like patch panels or keystone jacks. The tool pushes the wire into a slotted contact while simultaneously trimming the excess conductor. A properly punched connection creates a strong and consistent electrical path without the need for soldering or additional connectors. These tools are commonly used in structured cabling systems, particularly in office and data center environments. Patch panels and wall plates typically use 66 blocks for older voice connections and 110 blocks for modern data terminations. Each block type has its own pattern, and punchdown tools must be compatible with the block type. Always follow the labeled layout on the block to ensure correct wire placement. Many jacks are color-coded to help align the correct pairs. Using the wrong slot or punching down in the wrong order can lead to miswiring, which may not be immediately obvious during setup but will cause problems later under load. Recognizing a faulty punchdown is essential for troubleshooting. If a wire isn't fully seated or is mispunched into the wrong port, it may cause partial communication. Common symptoms include the ability to send traffic but not receive it, or strange one-way performance in certain applications. Loose punchdowns may pass initial link tests, but fail under sustained load or vibration. These types of faults often surface after desks are moved or cable trays are adjusted. A simple inspection and repunching of the suspect connection often resolves the issue. Cable testers are among the most widely used tools in physical layer diagnostics. Basic continuity testers check whether all pins connect properly from one end of the cable to the other. They detect open circuits, shorts, and miswires. Some models include remote units, allowing technicians to test long cable runs without needing a second person. These tools are useful for checking both pre-made patch cables and in-wall structured cabling. The tester cycles through each pin pair and displays the results via LEDs or a screen. Cable certifiers go a step further. While testers verify that the cable is connected correctly, certifiers validate that the cable meets a specific performance specification, such as Cat6 or Cat6A. These tools measure attenuation, crosstalk, return loss, and other metrics to ensure that the cable supports the bandwidth it was designed for. Certification is often required for large installations where the cable plant must meet warranty standards or building codes. Certifiers are more expensive than testers, but provide much deeper insight into performance and quality. Tone generators and probes, often referred to as fox and hound sets, help trace cables through walls, ceilings, or patch panels. The tone generator sends a signal down the wire, and the probe detects the signal through electromagnetic induction. The technician can then follow the tone to its endpoint without needing to physically follow the cable's entire length. These tools are especially useful in environments with large numbers of unlabeled or poorly labeled cables. They allow for fast identification without damaging the installation. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. A tool that's often overlooked but still valuable in certain testing scenarios is the loopback plug. This small device plugs into a network interface card or serial port and loops the transmit pins back to the receive pins. In doing so, it allows the device to test its own transmission and reception capabilities without needing to send traffic across a network. Loopback plugs are often used in router and switch diagnostics, especially when confirming whether a port is functioning properly in isolation. They're also useful when testing serial connections on legacy equipment. If a device reports link up with a loopback plug but not with a standard connection, the problem may lie further along the cable path or with the switch. Cable mapping tools, often referred to as wire mappers, go beyond basic continuity testing to provide a visual layout of the wiring configuration. These tools can detect whether the correct pins are connected to their corresponding counterparts and whether any wires are reversed, split, or crossed. Split pairs in particular may not be caught by basic testers, but are easily identified by wire mappers. For structured cabling validation, these tools ensure each cable run is wired precisely according to TIA/EIA standards. They also make quick work of verifying connections in environments with many terminated runs, like data centers or large office deployments. Documenting cable test results is an essential but sometimes neglected part of installation and troubleshooting. For small patch jobs, a technician may simply test the cable and move on. But for larger projects, such as wiring a new floor or building, documentation is critical. Certifier results can be exported and stored for future reference, giving facilities teams a baseline to compare against when performance issues arise later. These records also help identify trends, like recurring failures in a particular cable batch or consistent miswirings by an installer. Good documentation also supports warranty claims and future upgrades by confirming the existing infrastructure's capabilities. As with any hardware tool, proper safety and handling procedures are essential for both technician safety and equipment longevity. When using cutting and stripping tools, always follow best practices to avoid nicking the conductors or damaging the cable jacket. Overstripped cables can become brittle or expose too much of the conductor, which may lead to short circuits or poor seating in connectors. Likewise, crimpers and punchdown tools should be kept clean and stored properly. Dull or dirty blades make poor terminations and can permanently damage keystone jacks or patch panels. Calibrating and maintaining tools regularly ensures precision and prevents unnecessary rework. A field technician's toolkit should always include more than just the basics. Crimpers, punchdown tools, and testers are essential, but so are accessories like a label maker for tagging cables, spare keystone jacks and patch cords, and a flashlight for low-visibility environments like network closets. A tone probe makes cable tracing quicker, while a small mirror can help check labels or connections in tight spaces. Carrying the right gear reduces job site delays and gives technicians the flexibility to handle a range of cabling issues without returning to the office or waiting on another team. It's also important to recognize the limitations of certain wireless and simplified testing tools. Some modern cable testers include wireless capabilities or app-based monitoring, but may not catch all problems, especially subtle physical layer faults. For example, they may confirm continuity but not detect shield integrity loss, split pairs, or marginal return loss. When high performance is needed, such as in 10 Gbps environments, only certifiers can guarantee that a cable meets its category rating. Choosing the right tool for the job is key, and not every tester can be trusted for every environment. Use simple testers for quick checks, but rely on certifiers when performance and compliance matter. On the Network Plus exam, expect scenarios where a cable fault is described through symptoms. Perhaps a user's workstation can only connect at 100 Mbps, or a new patch cable prevents any link at all. You'll need to select the correct tool to diagnose or confirm the issue. This may involve choosing between a tone generator, a wire mapper, or a crimping tool based on the context. You may also be asked to identify signs of bad terminations, such as one-way communication or high error counts. The exam prioritizes real-world logic, so knowing the function of each tool and its purpose in troubleshooting will give you an edge. At the end of the day, cable testing tools are your first line of defense against physical layer issues. They allow you to verify, isolate, and fix connectivity problems with minimal guesswork. Whether you're validating a new install, replacing a suspect patch cable, or tracing a line through a crowded network closet, having the right tool and knowing how to use it makes all the difference. Many common problems in networking can be resolved before you even touch a configuration file, simply by starting with the cable. To recap, crimpers terminate modular connectors, punchdown tools handle structured wiring panels, testers confirm basic continuity, certifiers validate performance to spec, tone generators help trace runs, and loopback plugs isolate port-level issues. Together, these tools cover nearly every scenario involving physical connectivity. They are inexpensive, fast, and effective, qualities that make them invaluable to every technician and test taker. Understanding cable tools gives you the confidence to approach problems from the ground up and solve them before they escalate into more complex failures. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.